Hello guys, welcome in today's session. I am Professor Fayaz Karadi from Department of Mechanical Engineering. In today's session, we are going to discuss the introduction part of gyroscope with some applications from unit number 6, gyroscope from theory of machine subject. When a body moves along a curved path with uniform linear velocity, a force in the direction of centripetal acceleration has to be applied externally over the body in order to move it along a curved path. This external force applied is called a centripetal force or active force. That force you might experience while driving a two-wheeler along a curved path. That means if the vehicle is taking left turn, you have to tilt the vehicle towards left for taking the left turn, and while taking the right turn you apply the force towards the right side while taking the right turn along the curved path. That things is happen only while taking the turn on a curved path. This externally applied force by the driver is called as a centripetal force or active force. Similarly, when a body itself is moving with uniform linear velocity along a curved path, then it is subjected to a radially outward force. This force is called as a centrifugal force or reactive force. It is important to note that whenever the effect of any force or couple over a moving or rotating body is to be considered, it should be with respect to a reactive force and not with respect to active force. A space gyroscope is a mechanical device which contains a heavy metal rotor. This rotor is mounted in such a way that it has 3 degrees of freedom. In figure you can see the rotor is in yellow color. This rotor is a heavy mass rotating about a axis. That axis is called as a spin axis. When that heavy mass is rotating about spin axis along with two other perpendicular mutually axis, at that time this rotor have 3 degrees of freedom, and this device is called as a gyroscope, as you can see in the animation. These 3 degrees of freedom, now you can see this image. First degree of freedom is in figure A. Heavy rotor is rotating about x-axis, is fixed about x-axis, and in figure B, that heavy rotor is rotating about x-axis, so that x-axis is called as a spinning axis and the motion is called as a spinning freedom. Second, this rotor along with x-axis is tilting along along z axis, which is in a single plane. It is on same plane but it is perpendicular to x-axis. So that rotating axis along zz is called as a tilting freedom, and that axis is called as a tilting axis. Third one is a weaving freedom, that a rotating mass is rotating along axis along zz, and at the same time it is rotating about third mutually perpendicular axis yy, and that yy axis is called as a weaving freedom. Remember that these 3 axes on which that rotor is rotating are mutually perpendicular to each other. The degree of freedom of a rotor are obtained by mounting it between 2 concentrically pivoted rings. These rings are called as an inner gimbal or outer gimbal respectively. In figure you can see this is an inner gimbal on which that axis is mounted or pivoted at two different positions. This is one position, this is second position at right side of the observer. So this is called as a inner gimbal, and at the same time this inner gimbal is mounted with the ZZ axis, that is called as a outer gimbal. This complete assembly is called as a gimbal system of a space gyroscope. It is mounted on a frame in such a way that under normal operating conditions, all the axes which are mutually perpendicular to each other will intersect at the center of gravity of the rotor. Now, see some of the applications of gyroscope which you can see in our daily life. The gyroscope principle is used in an instruments or toys called as gyroscope. Here you can see antique doll, unusual cast metal gyroscope toy. The second application, the gyroscope are installed in aeroplane, monorail cars, gyro, compass, etc. Okay. These gyroscope are installed in aeroplanes, monorail cars, gyro compasses in ship also. Here you can see the aeroplane in which that aeroplane is pitching, yawing and rolling in three different planes. The third application is the gyroscope are installed in ship in order to minimize the rolling and pitching effect of the waves. Okay, when you see in front view, you can see the rolling action of the ship, and when you can see inside view, you can see the pitching action of the ship. That rolling and pitching is happen in the ship, and to overcome this effect, rolling and pitching effect, the gyroscope is installed in the ship. It is also used in important application like bomb sites, control of aeroplane and guided missiles. The vehicle are also work on gyroscopic principle while taking a turn. The last and next application of the gyroscope is our Earth. The Earth is spinning on its axis and the cycle period is one solar day. When the Earth is rotating about in its own axis, this own axis is called as a spinning axis. The orbital movement around the sun is called as a rotating axis, and the cycle period is one solar year. And the third one is a precision motion, gyroscopic wobble about the rotation axis, and the cyclic period is 25,920 years. So the Earth wobbles like a gyroscope in space, and that spinning precision is very slowly. So the Earth wobble like a gyroscope in space, spinning once per day while it circles around the sun during its annual course. So our Earth is also work on gyroscopic effect. So at the end of this session, the student can understood the introduction part of the gyroscope with help of some applications. Thank you for watching this video.